Okay, so today we're going to talk about natural language interfaces. We had a lecture already on large language models, but basically talking about the technology of how you build such things. But today we're going to talk about if somebody has built them, how do you use them? How do you integrate them into your product? First news of the day, generated another novel logo. This morning, there's all these rumors of ChatGPT 5.1's coming out soon and Gemini 3's coming out soon, and everyone's getting excited. And it's starting to remind me of, the car buffs. Every year they say, oh, new models are coming out. And it reminds me in two ways. One, the enthusiasts get really excited about that. And two, the rest of the world says, this year's model seems pretty much the same. I'm not sure there's a lot of difference there. So when these come out in a couple of weeks or whatever, we'll see. Are they pretty much the same or are they a big advance? Here's an article. So a scientist did a lot of work on mosquito prevention and published an article in a prestigious medical journal. And then somebody wrote in with a letter. And so the idea is, they publish these big articles that take a long time to do, and then anybody can write in and say, here's a letter, I noticed a mistake in this article, I want this recorded in the journal. And the thing is, if you're counting up your citations, that tiny little letter counts one just the same as a big article. And so here's one author who, up to 2023, had never written a letter of that kind. In 2024, he got 200 and something letters published, and he's on a better pace now. And this author said, I looked at some of these. They were trying to write letters commenting on my article, and it looks like they were all done by ChatGPT, right? So it's a new way to get your citation count up and become a highly published author, is just run an article through ChatGPT and submit that as a letter. And so now we're going to need defenses against that. We talked a lot about security being really important. There was this heist at the Louvre. I don't think this had anything to do with the heist, but their password was Louvre. That's probably not the best password they could have chosen. So if you're in charge of security, make sure you do a better job of that. Okay, so this really isn't news of the day, but this happened to me yesterday. I'm walking down the street and I see this little bag has been put on this post, and probably what happened is somebody dropped the bag and then somebody came by and said, oh, here's a bag on the ground. I'll put it up on this post so that the owner has a better chance of coming back and finding it. And I thought, is there a better way to reunite the owner with this lost article? And I know there are things like Nextdoor and sort of these neighborhood groups where you could post a little notice saying, hey, I found this thing. But is that the best way to do it? And so might want to ask you to talk with your neighbor for a little bit and say, suppose I wanted to create an online site to reunite their owner with this bag and everybody else. How would you do that? What role would AI play in building such a site? And what are all the safety and privacy and security issues? What attacks? How could you be making people vulnerable by providing this service? And how could you defend against that? So talk about that with your neighbor for a bit. Okay, all right. So what do you think? Is it feasible to build such a site? If it is, how would it operate? What'd you guys come up with?
Instead of having the gallery of all objects that were lost, which might not bring the right person to the item always, it's better to have a system where like the user who lost their object has to describe it first, and then say like when they lost it, what it looks like a little bit, and based off of that information, the AI can look at its like full of information, and if something seems to like pertain to that object, surface it up, and then there'd be a couple questions that the model asks, being like, is the bag blue or is it black, or like things that kind of just try to gauge if this is really the object, or protect the object from like a malicious act.
Yeah, so I think that's great, right? So one of the attacks you have to defend against, if you're sort of putting up pictures of things that were lost, anybody can come along and say, yeah, that's mine, and harvest free stuff. So having this kind of verification is a good way to do that. And I've certainly seen that before, when people like post notes that says, I found this thing here on such and such a date, and I took it home with me, and if you can describe it, I'll give it back to you. So having some kind of protocol where you go back and forth is a good thing. If the site gets too big, right? So probably, if you do something like that locally in Palo Alto, probably you get pretty good matches. If you did it in New York City, there could still be people that just come in and said, and guess at something, and they're probably going to get a hit if they do that. So there might be better ways to deal with that, but that's certainly one of the attacks, and seems like this would defend against it. And it does seem like AI could play a good role in having that back and forth, right? Coming up with the questions that say, ask the color or whatever. What are other possible attacks? So how do you actually do this reuniting, right? So is it that if, I saw the bag there, should I leave the bag there and post a note about it? Should I take the bag with me and have somebody meet me? Should there be a place where I could bring it? How do you think that would work? And what are the sort of security and privacy and safety trade-offs around that?
So this is like a startup. It kind of reminds me of like the new lockers that Stanford has put in place with the Amazon packaging.
Yeah.
It's like it sends you a QR code. You can like drop off the item into one of the lockers, close it, and then the QR code that's sent to the person to go ahead and find it. And the reason why I propose that is I think there's like a logistic cost of like to hold on to the item, and you have to try to like meet multiple people. I think that puts a lot of burden on the person who's trying to do a good deed. So it's trying to kind of lift some of that.
Yeah. So I agree with that it does seem like it would be a bigger burden, and there also could be a safety issue. So, you don't want to go meet a stranger at some place. Although Dan has an interesting story about exactly this problem.
Well, the problem was my daughter had exactly the situation where she lost her Clipper card. This is on the streets of wild downtown Berkeley, and someone found it. and then to figure out her email address from the information on the card. They met at a local coffee shop. He said, so we'll meet at this coffee shop, which turned out to be exactly, I think, 50 yards from her house. It's also 50 yards from his apartment. And they're in the same neighborhood, and now they're boyfriend girlfriend. So it's a cute story. But with the information on the card, I was able to figure out her email address at birthday. So doing the obvious moves. So that was a special situation.
Right.
Of a hyper-local neighborhood.
Right. So there can be unintended good consequences of technology or of lack of technology, but there can also be unintended bad consequences. And I think we caught a couple of those for this. Okay, so brief history of human-computer interaction modes. So in the 1940s, we had things that we called computers, and they were people, right? So the people did these computations, mostly women, and they had a little bit of support for that. There are these adding machines here. If you wanted to do something really complicated like multiplying, then the adding machines couldn't do it. This is called a slide rule, which uses logarithms to do multiplication. And the speed was about 0.1 operations per second. Then in the late 40s and 50s, we started to get these first computers programmed by wiring them together. Again, most of the work done by the women who were previously doing the paper and pencil calculations. They kind of felt like, oh, you know, the serious hardware stuff, the men can do that. And software, well, that's easy, so we'll let the women do that. And the women were the ones that discovered maybe it wasn't so easy. These first applications, as is often the case for technology, right? There's kind of two things that drive technology, and one is pornography and the other is war. In this case, it was war. So they were trying to compute trajectories of firing artillery shells and using sort of solving differential equations that couldn't be solved analytically, solving them computationally. And I thought, you know, these women who kind of invented software, they deserve a motto. And since they were solving differential equations, I thought we should call them Rosie the Derivator. And AI Art did a pretty good job here. It took a couple of iterations. The AI Art, when I said, you know, computers in the background, they really wanted to have modern keyboards and disk drives and things. And I had to say, no, 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 go back farther in history. But eventually got one that was okay. Okay, so then we started advancing and said, well, you no longer have to wire things together. You can punch holes in pieces of paper and we can read those in. And then eventually we got to the point of the command line and various operating systems that allowed you to communicate directly with the computer for the first time. And Neil Stephenson wrote this interesting book about it. He describes Mac OS as being like the big fancy expensive sports car, Windows as being the clunky utility car, and Linux being the tank. But you can do really powerful things at it. You can do this whole, let's take all the names, let's reverse them, last name first, sort them, remove duplicates, and reformat it as a nice table. If you knew all these commands, it might be easier to say this than to say the sentence I just said in English. If you don't know those commands, then you're really stuck. So in some sense, this type of interface was maybe even more powerful than a chatbot, but relies on a lot of knowledge on the part of the user. Okay, and then we said, well, that command line is too complicated for most general users, so we got this GUI interface, or sometimes called the WIMP interface, for Windows icons, menus, and pointers. And then started figuring out, well, what's it going to look like? It's a visual interface, but what it's going to look like? And in the very early days, we said, well, it should kind of look like things in the physical world, but the graphics are lousy. And then the graphics started to get better and imitate things in the physical world more. We use this fancy word skeuomorphic to mean referring to analogies of things in the physical world. And sometimes I think that's taken too far, right? So here's the iPad that's trying to duplicate this physical newsstand. But it feels like you could be a lot more efficient and represent more information than it does using this form. And notice there did seem to be a backlash against that. So the more modern UIs are less fidelity to the real world and much more simplified, right? We did away with all those pictures of things in the world. Now we just have these flat kind of tiles. And then we invented a new interface of touch, which is different than using the mouse, using your fingers. And so we've evolved over the years. Then tried to get away from interacting everything on a screen to using these wearables. And so far, this has not been very successful, right? So studies say people buy these watches or Fitbits or whatever, and half of them give up after 6 months. They say that this isn't worth it to me. I think part of that might be that they got value out of it for 6 months of saying, I want to know what my heartbeat is like when I'm jogging or when I'm running fast or whatever. And then after 6 months, you have a pretty good idea, and you don't need it anymore because you can judge yourself. Say, okay, I'm doing this now. I feel like my heartbeat's about 120. I don't need a watch anymore to tell me what it is.
Quick comment on this. I know most of you seeing that number say, that's great. What are you talking about? I want to remind you that one of the fundamental things about HCI, like UX research, is that you are probably not represented. You're extraordinarily not represented. This is true for the entire United States. You are not the United States. So it's really important that when you're doing research on HCI for these kinds of things, that you have to look outside of your cohort. Because all of you have got a Fitbit or an Apple Watch or something like that, and you've had it for a year or 2 or 3. So how could that possibly be true? It's true in the aggregate. That's not your individual experience. You have to remember this. Just tattoo that on your floor.
So you are not the US, and the US is not the world. And then we've seen further attempts to go farther than just those wearables into AI wearables. So there's these various pins shown on the top row that you can attach. None of those has taken off, and it's not clear that they do anything that your phone couldn't do. And then augmented reality and virtual reality down here. Do you want to walk around in a 3D world that's completely generated, or do you want to have pop-up displays on top of that 3D world? That hasn't taken off yet, although I think there's still a chance. I think it could be that in a few years, a lot of people will be wearing something similar to these Meta glasses, because it is more convenient to have your 2 hands free than to have one of them occupied by holding this. And then you see things like these earbuds are advertised as translator earbuds. They do real-time translation from one language to another. I don't see any super advantage to that. It feels like you can connect your earbuds to your phone. You could do that all through your phone. Why do you need special earbuds to do the translation? Okay. Now, over the last few years, we've seen the rise of this voice user interface. And I remember when this product launched, and I thought it was stupid. I said, what's the advantage of taking away my keyboard and my mouse and my screen? You're only making it worse. And that goes to show why I'm not a product manager. I'm just a lowly engineer, because these things are pretty successful. And so they take sound waves in, and what do they produce out? If you want to do the speech recognition, well, certainly words, but it's more than that. Right? So recognizing speech is not just recognizing the words. One thing that's important is speaker ID, right? So you've got one of these things in the kitchen, and you say, "Hey, what's my calendar for today?" You have to know who I am, because there might be multiple people in the household who are registered with it. So where you are, if you say, what's the weather today? You got to know where you are. The emotion and the emphasis, it's this, not that. You have to understand that it's more than just the literal words. Is this sarcasm? You want to respond in a different way. What's the user's intent? So all those things are important. I wanted to play this clip from this movie, My Cousin Vinny. So this character here was falsely arrested and accused of something he didn't commit, and he's baffled by that.
When'd you shoot him? What? At what point did you shoot the clerk?
I shot the clerk.
Yes, when did you shoot him?
I shot the clerk.
Hey, Dean, we need you out here. I'm in the middle of a damn confession here.
Whoa! Wait a minute!
I asked him if he did it, and he said, I shot the clerk. I asked him again, and again he said, I shot the clerk.
Your Honor, no further questions.
Okay, so it was 100% accurate transcription to say, he said, I shot the clerk. But there's a big difference between saying, I shot the clerk and I shot the clerk. And that doesn't come through if all you're getting is words. So it's important to do more than that. I want to talk about this science fiction book. Came out in 1995, so it's pretty old by now. Been very influential. And in this, it imagines a future world in which most people can't read. So it's kind of extrapolating. And that's well before the iPhone came out. But somehow Neil Stephenson said, looks like we're going in that direction. And so most people can't read. They use these voice user interfaces, and they use these things called media glyphs, which is, it's a book, not a movie, so I can't tell exactly what he meant, but it seemed like some mix of emojis and GIFs. And then there's this interactive book called The Young Lady's Illustrated Primer, which is voice activated and teaches you everything you need to know. And interestingly, Stevenson imagined it as there's sort of a mechanical Turk voice actors, that the book is smart enough to know how to respond to the student and know exactly what to say. But in 1995, speech generation was really lousy and sort of monotone and so on. And so Stevenson imagined that you'd have to call out to a voice actor who would actually read it. They wouldn't decide what to say, but they would read it. I thought that was really interesting. I thought it was a great choice to say, we're not going to get everything right, and we may need some humans in the loop to do something. Putting emotion into the voice is clearly not the right thing, because already now we have speech generation that does get that kind of emotion. But I do remember I was once on a panel with Neil Stephenson about AI in education, and I told him, in 1995, you invented this thing that we've all been trying to duplicate. And he said, I didn't invent anything. I just wrote about this idea. It's up to you guys to invent it. If I had invented it, I'd be rich now. I don't know how to build that. So there's a chance for all of us to make this vision come true. Okay, so we've got these devices, and the only way you can interact with them is to talk with them. And the biggest issue is discoverability. So it's kind of like going back to the command line, right? So we built these GUI interfaces that had these menus, because if you didn't know what commands to do, you could just click on the menu and say, okay, here's the list of commands. You can't do that with one of these speakers. There's no list of commands. And you could take this approach of saying, well, it's just like talking to a person. I can say anything I want. But then they don't deliver on that, because they can't do everything. They can only do a limited amount of things. So how do you figure out what is it that you can say that will work and what won't? So let's discuss again with your neighbor. How do you know what you can say to Alexa or Siri or Google? And how would you design the voice user interface to make that more discoverable by the user?
Yeah, that's more of a capability of like inspired rather than yeah. I think
Okay. So I don't have the exact numbers, but a huge percentage of the usage of these devices falls into a very small set of categories. It's what's the weather, show me a recipe, play a song, set a timer.
I happen to know the data.
You happen to know this, okay.
Music is 75% of all other episodes are played, song by the Beastie Boys or something like that.
Right. And the other things I mentioned are a good proportion of the remaining 25%. So as a general purpose device, these things have not reached their potential, but they found a few small things they can do. How can we make them better? How could we make the users aware of what else it can do? Who has suggestions?
I was thinking Spotify has a feature that's called DJ that will like play recommended songs for you.
Uh-huh.
But the interesting thing is that 90% of the time it does its normal behavior and it'll just play the next song. But 10% of the time it gives you like a usage recommendation. It's like, did you know you can click this button and tell me what song you want to play?
Yeah.
But like we do a similar thing with voice assistant where 90% of the time it reacts to your query normally, and 10% of the time it could patient behaviors predict the usage of mechanisms. Sort of, it's kind of different historical behavior. So you could slowly discover more features.
Yeah. So that's a great idea, and certainly that's a really important thing to do, is to give the users, oh, here's an example of something you can say that you couldn't say before. I think it's a little bit difficult here because on a screen, it's really easy to pop up a little window that says, here's an example. And if you're interested, you can pay attention to that and say, oh, okay, I'll remember that. And if you're not interested, it doesn't really interrupt you. But with the voice interface, it's only got one channel. If it's talking to you and saying something that you don't care about, that's kind of a negative, right? So you've got to be pretty sure, right? If you are talking, you've got to say this has got to be something that the user's probably going to be interested in. Anybody else have other ideas?
So right now we have a response to you, but instead So I have a conversation with you know, this is a partnership with small facts.
Yeah. Yeah, I think that's right. And that's a good thing to do. Again, you don't want to do it if you're kind of interrupting the user. And so you can kind of try to figure out what the right time is to do something by just listening. And, you know, if two people are in a conversation, you don't want to butt in, but if it's quiet, then maybe that's the right thing to do. Some of these devices are more limited than others, right? So how do you even know there's somebody in the room that you can start a conversation with, right? You don't want it speaking when there's nobody there. People think there's ghosts in the house. And so that's why I think it's interesting that I showed these three devices here that are just the speaker, but we're starting to see some of these and the screen comes back. And importantly, a camera often comes back too. And there are privacy concerns about the camera, but it is really useful for it to be able to see, well, who's in the room and what are they doing? Are they interacting with each other, or is it okay for me to interrupt? So trying to get that right is a challenge. Okay, so more on interacting in the physical world. My daughter had this app, and this was way back in 2012. And this is an interval training app that you put on your phone. And what it says is, the zombies are right behind you. Start running quickly. And then a little bit while later, it says, phew, I think we lost them. You can slow down now. So it's getting you to do this interval training of when you're running and when you're walking. I thought the premise was a little bit off because, as I understand it, zombies don't run that fast. But still, a lot of users found this really entertaining and useful, and it encouraged them to run and train more than they would if they didn't have that kind of feedback. Okay, so that's one. On a more sort of serious academic level, here's this thing called Who is Zuki? There's this paper you can see. Marani is the main author. James Landy here at Stanford was the head faculty member. And this is designing sort of a story that encourages you to go out and be physical and walk around in the world. And they found that the more complicated you make the story, the more engaging it is to the users. Then there was a big push on this game called Pokemon Go, which envisioned these creatures out there in the world. You know, here it looks like they're really there, but actually they're just on your phone. You point the phone and it's augmented reality, and there's a creature over there. And so part of the point of this was there's all this criticism that people are just sitting on the couch scrolling their phone. Can we make an app that will get them to go out into the real world and interact with the world, interact with each other, get some exercise? Okay, so to some sense, that was really successful. In another sense, it got a lot of criticism for some things that went wrong. So what special concerns do you need to consider when you're designing a product that interacts in the real outdoor world rather than just the virtual world? Discuss that.
Oh my God, it's such a good
And so like everyone can use those.
Yeah, that's true.
That's also, and so things like open data, you can see that, like, yeah. Basically encouraging people to wander around. Here over enterprise.
All right. What are some things we need to worry about before we launch this product? Yeah, I think that's definitely right, right? It's more dangerous to be out in the real world than to be sitting on your couch. And there were lots of reports of people staring at their phone and walking out into traffic and getting hit or almost getting hit. In some sense, that's similar to just the advice of be aware when you're out in the world, right? So it doesn't take a game, right? We know that you shouldn't be texting while you're driving. And is there anything about the game that makes it worse than other kinds of distractions when you're out in the world? Or maybe it's like, so you mentioned the immersion aspect. So maybe if the game's really more exciting, then maybe you're more likely to be paying attention to it than just when you're texting or doing anything else. Any other concerns?
It's kind of like that, but just the fact that everyone's a lot higher than if you do on your couch, but like it's a good point that, you know, there's still other distractions and it's probably the nature of the design of the virtual application that might influence and need to be aware of.
Yeah, I think that's really right, right? So, you know, when you're designing a video game, sort of you're in control, and only a certain number of things can happen. But in the real world, everything can happen. I think that was one of the points that Andrew Chapman was talking about when he was here describing Waymo. And he said, you know, when we move into a new city, you might think, well, it's the same as every other city. You stop on red and you go on green. But he said, no, each city is different and has its own unique things. And so you do have to worry about that. Any other concerns?
Very intentional about the design of the school because like, depending on how you design it, it can have different implications for safety. So for example, I'm thinking about this one sense, like the VR headsets give you a very different experience, especially the ones that have like reality. Like they give you a very different experience than like meta ray classes, for example.
Yeah.
But something like meta ray bands are classes that you could like if you're driving by. Obviously, then it says that's a good.
Yeah.
But doesn't be very clear about the use for the specific tools that I'm using. This is something that I did. It doesn't cause as much harm as.
Yeah, I think that's right. Right. And so this was clearly, in this case, was augmented reality. But you're right that there are a lot of concerns for full virtual reality immersion as well. And there's a lot of positive use cases. if you're walking around in this virtual world and you turn your head and something happens, you do feel more immersed. And there are studies that say you retain more information, it makes a bigger impact on you than if you were just watching on a screen or doing augmented reality. But it does become more dangerous. You can trip over things, so on. Another concern that came up when you saw a lot of newspaper reports is people using, criminals using this to attract people to a place where there were some Pokemons and then being able to rob them. And there's certainly lots of ways that criminals can rob people, but the fact that this is one possibility, I don't know if it really made it worse if they would have done the same crime someplace else, but if it gets associated with your product, that's a bad thing. So you want to defend against it, even if there isn't any additional risk. You want to make sure you minimize the risk. Okay, so command line interfaces were powerful, but kind of only if you really understand what's going on. It's a slow learning curve to be able to figure that out. The GUI and WIMP interface made all the commands more discoverable. You didn't have to memorize the command. You could just poke through the menus and find them. You could identify things by pointing at them, say this thing, and move it over here rather than having to type in the names of paths of files and so on. One problem was that you couldn't chain those programs together, right? So in the command line, you can take the output of one program, feed it into another program, feed it into the next program. You can't easily do that with taking the output from Photoshop and feeding it into another program and feeding that into another program. You can drag and drop, but you can't do it in an automated way like you can with the command line. And then voice, you can say anything, but it may not understand everything. And I think we're sort of right at a turning point now, right? So these voice interfaces so far were programmed with kind of sets of rules of here's how you respond to play a song or some other request. And the main companies are now starting to roll out this integration with their large language models. And so that will change. They'll suddenly become much more responsive and able to do much more things. And for all of them, you have to consider accessibility. What if I can't hear? I can't use the voice user interface. What am I going to use instead? And consider internationalization, different languages, and different cultural expectations. Okay, now of the two natural language modalities, we have text and voice. And sometimes I think about, what if I was an entrepreneur and I wanted to pitch this idea of, I have this new technology called reading and writing, and I want to roll that out to everybody. And by the way, I'm going to need like the next 8 years of every student's life in the classroom is going to be mostly devoted to them learning my technology. I don't think I get very far pitching that idea. And yet, as a culture, we decided it is actually worth it, that there is a big advantage to text. So spoken language allowed us to communicate with each other and build up civilizations and communities, but it was really written text that allows that to pass from one generation to the next. And so there are huge advantages to it. But it's hard. It takes you many, many years to learn to read and write. About 5% of people don't really do it, or they learn only at a very minimal level. And then 20% of all learners don't make it to the advanced, to even like the high school level. It's slower to write things out than it is to speak them, although it is faster to read them, right? So I can read quickly, I can skim, I can go ahead, and I can't do that with a voice interface. I often feel frustrated by that. If you train yourself, you can do better. So, I often listen to a podcast at 1.5 speed because I want it to go faster. I have a friend who's blind and has no other choice. He listens to everything at 6x speed, which I just can't comprehend. But you can train yourself to do that. Okay, And so voice interface, everybody learns how to do that. Very low failure rate. There are very few people who don't learn to speak their own natural language. Dictation is faster than typing, but it's slower to listen. And it's harder to skim or search. So I often prefer text, as I said, I want to go down to the good part and get there right away. It's harder to do that with a podcast than it is with reading an article. Okay. What about the really complex tools? So here's Photoshop. I use it a little bit. Photography is one of my hobbies, so I feel kind of invested in it. But I probably know 10% of what's in all those menus, maybe less. And so you often have to dig really deep. I go to the file menu, I go to export, I go to export as, and there's 3 dots, which means it pops up another thing, and then there's 20 other things I have to specify. So this is really hard. And it's hard to manipulate your way through the menus. I'm not sure if it would be less hard or more hard to speak the same thing. I think a lot of it comes down to, can you automatically get the right defaults? And can you recognize the situation where I want something different than the default? Can we have the system help you do that rather than require the user to check all the checkboxes and so on? So I wanted to challenge you now. Let's suppose that natural language technology is 100% perfect. You can say anything you want to an LLM and it will understand everything completely perfectly. In what cases would you use a text interface or a voice interface or a GUI interface like this or something else, right? What's the right interface to Photoshop, and what's the right interface to other types of applications? When is natural language the right thing to use? So have a discussion about that, choose 1 or 2 applications, and figure out what you think is the right interface to that.
I don't even understand.
Yeah, but like I think it's I think in this area,
Okay. What'd you come up with? What applications did you discuss, and what's the right interface for them? Who has something they want to say? So I know we had one suggestion that says, while we're dreaming for the perfect technology, what about the Neuralink, where you just think it and you don't have to say anything and it knows exactly what you want? So maybe that's the good interface. Although even then, I'm not sure it's 100% the answer, right? So yes, if you could say anything you want and it can understand you, that seems good. It seems like that solves most problems. But what if you don't have the words to describe it? Or what if it's easier to describe with a picture rather than with words? What else did you guys come up with? What you discuss?
We talked about how we mostly use text, and it's sort of, there's like stuff that can do, something that would require like conversation instead of like just the efficiency of words, I guess. Because we're talking about like how a person is doing this, like type something out instead of saying what you want.
Yeah.
But if you were to do something that would require conversation as like the main feature, like building a therapy, then voice would be on campus.
Yeah, so I think there's this feeling that voice is kind of more casual and text is more formal. So if you're trying to do something complicated, maybe you go more towards text. Also, text is easier to review and to edit. And so that seems like a difference. I know some people mention the idea of, well, you can't always use voice because sometimes you're in a place where it would be rude or someone would overhear you, and you don't want that to happen. So there's a privacy advantage to using text. Anything else people discussed? Okay. And so here's just the history of the hardware. And as we go forward in time, it seems like the devices are getting smaller and smaller and yet more powerful. So the power per cubic inch is going up doubly fast. And went from room-size mainframe to this size PCs to this size smartphones, and now we have rings and contact lenses and even smaller devices. Another big question is, who's in control with these devices? So in the early days, the only people that had a computer were big companies. And so who was in control? It was your employer. You had access to it. Then we got personal computers. And in those early days, you had complete control over what software you wanted to run on your machine. So it really, you didn't feel, it had the name personal in the computer. And it really did feel like this was yours. If you sat down at somebody else's computer, you couldn't do your work because you didn't have the same software delivered on them. And then we got to phones where many companies are involved, right? So you got all these icons on your home screen and you can press anyone, and you're giving control over to that company, and you got to trust them. With the voice interfaces, now you're just talking to one company, right? I'm talking to Amazon or Google or Apple, and they're in complete control. I'm not handing off my phone to Uber at one point and others at another. Yes, I can use them to call Spotify, but it feels more like one company is in control. I think there's a possible future where we really get back to the personal computer model. We say, I'm interacting with a language model on my phone, and I really feel like it's my language model. And then it's calling out to all these services for all these companies. And a lot of privacy advocates and so on think that that might be a better future than where we are today. Okay. So language models, and linguists for many decades have said, well, there's a lot going on in language. At the shallower level at the top, we have the speech and text input, and then we interpret that in terms of phonetics and morphology, and then syntax and semantics and so on. And in earlier days, each of these was studied independently and within linguistics, and then within computer science and natural language processing, we took the same kind of approach, and we have this pipeline. You built individual components to take in the text, break it up into words, pass it off to get syntactic analysis, and so on and so on. Tried to do each of those steps. Some of the steps had to correct for errors in the earlier steps, and that was difficult. And there's more breakdown than that. So taking just the first one of lexical analysis, it's got all these parts in it as well. So it's a really complicated pipeline, and we were kind of using machine learning, but also writing code for each one of those steps. So phonology, you have to figure out what the sounds are. Tokenization, you have to take in a sentence and break it up into words. In English, that's really easy. In other languages like Chinese, it's more difficult to know where the words are. Then some of the words can be broken up into components. It seemed to be helpful to assign parts of speech to the various words and then build these grammatical trees. And I got to say, this comes out of the textbook by Professor Jurafsky here at Stanford. And I happened to run into him this morning at Bytes. And I told him, Dan, I feel sorry, but last year we had a bunch of slides from your book explaining in detail how to do each one of these steps. And I took them all out because people don't do that anymore. And he said, yes, you're exactly right. Right? It used to be we spent all this time programming each of those steps in the pipeline. And now we don't do that anymore, right? So we had all these technology and these formulas and so on. We don't do them. And now everybody uses this end-to-end approach. Just saying, we take the data, maybe it's annotated in some way, we put it in a end-to-end learning in this deep neural net, and then we get the output. And to me, I think the main reason why this approach won is because breaking the problem up into a pipeline was just an approximation, right? So we invented this idea that there's morphology and there's syntax and there's semantics and so on. And yes, it felt kind of coherent, but each one of those steps really interacted with each other in ways that was hard to write down the interactions. And so what we did is we said, let's guess the right answer at each step. And then if we guess wrong, have the next step try to correct it. And that was just really hard to do. And what deep learning does is says, we can put all of these together and we don't have to rely on one step correcting the previous one, because instead of being chunk by chunk in very simple models, we have a very complex model where everything's happening at once. And if we had to program it by hand, that approach would be terrible. decomposition is a powerful tool in programming by hand, but in machine learning, often going end to end ends up being more powerful. And that's what's happened. So if you'd asked me 2 years ago, there would have been a lot of votes still for this, break it up into components and solve each component independently. I saw that at Google, where lots of teams proposed solutions like that. And some people would object and say, well, you could just use the end-to-end deep learning model. And they had good reasons why that wouldn't work as well. It was easier to do it the simpler way. Now that's all going away and everybody's going towards this approach. Okay, so we decided that we want these large language models, but what metaphor applies to them? How do we understand what they can do? So this paper by Emily Bender and colleagues, it's way back in 2021, said, well, these language models are just stochastic parrots. They just take in the text and make a probabilistic model and then spit something out. So if you believe that, then you believe, oh, they can't possibly really understand what's going on. And that seemed like a criticism. Some people felt like, no, they're more than stochastic parrots. In fact, they're real people with real souls. They came to believe that they had life. That seems a little bit far out there, but it was a metaphor that convinced a lot of people. Ted Chiang, science fiction writer, said ChatGPT is a blurry JPEG of the web. And what he meant is we train ChatGPT by giving it all the stuff on the web. And what's a JPEG? Well, JPEG is a compression. It takes a picture with all the detail in the picture, and it tries to throw away the details that don't matter so that the file will be smaller. And that is true, that's to an extent, that's what chatbots are doing. They're taking everything they know and compressing it down and trying to keep the important stuff and throw away the less important stuff. And Chang's argument in 2023 is that when you do that, you inevitably lose some valuable stuff as well. And that's one way to look at it. But I think we've seen over time that everybody who has this criticism of here's something it gets wrong, then as we saw in News of the Day, the new model comes out and often they get it right. So those criticisms tend to fade. Okay, and then Microsoft came up with this article saying we see sparks of artificial general intelligence. And so this other metaphor is if these systems keep getting better and better, then eventually we're on a trajectory where it'll be artificial general intelligence, it'll be as smart as the smartest person. And some people see us on a clear path to getting that. And other people say, no, we got to fundamentally change what we're doing because we're just stochastic parrots and we have to get better than this. So those are the metaphors. There is an underlying reality. We are running a piece of software and it does a particular thing, but it's really hard for us to understand what that thing is. And these metaphors help us. They each take an incorrect but impartial view on what's going on. Okay, so what can you do with natural language? So you can just have a conversation, but there's all these other parts along the way that can be helpful. Speech recognition, so that you can do dictation, having the conversation, doing translation from one language to another, doing summarization, doing classification and sentiment analysis. Is this say this movie was good or bad? Clustering similar things together, doing recommendations. If you like this book or this movie, you'll probably like this other one. Information retrieval, which is what Google was built on, question answering, and so on and so on. And I go through some of them quickly. So one of the earliest applications of natural language was text classification. You get some email coming in, some of them are spam and some of them are not, and you build a system that decides which one. Sentiment analysis, you get a review for a movie or any kind of sentence and you say, is this positive or negative? And I think this is interesting enough that, let's play with that for a little bit. So I forgot to put the QR code, but the URL is pretty simple. Text number 2 data.com/demo. Okay, so why did I ask you to play with that out of all the tools on the web you could play with? For 2 reasons. One is sentiment analysis by itself is a really important tool that's used everywhere around the web. Right? So all the companies want to know, did people like this or not like it? Are these comments good or bad? So it's as a standalone application, it's really important. But also, this gives you some insight into what it's like to be a large language model, how it picks out certain words, how it combines those words together. By playing with this a little bit, you can get some of the feeling for what's going on there. Okay. Then another thing that we've all had experience with is figuring out how to do corrections. So it used to be, we got these little squirrely red or other colored lines only when we did a typo, when a word wasn't in the dictionary. And now it's trying to do a lot more. It's trying to do grammar and so on. So this is some of Dan's text with some errors in it.
First time I've seen this. It's great.
What? You put it in?
Yeah.
Yeah. I didn't do this.
Keep going.
Some magic genie put these size in?
I assume the AI system.
I guess so, yeah. All right, it's mystery where it came from. So it's important to get this stuff right, but it's interesting how people kind of figured out what the right way to do this is. So one thing is, you don't want to be too intrusive, especially if you make a suggestion wrong, but you want to make it clear enough that, here's where you should pay some attention. So you can go in here and note that here it's saying specifically that recognize that there's a difference between American and British spelling, and that's why I'm making this suggestion. Here, there aren't, so blue underlined means that it's grammar rather than spelling, and it's making a suggestion of another way to say this. Here, it's just clear that it was just a spelling error. But you get more options there, and you can give feedback. You can say, this suggestion is just wrong. And from that, the model can improve and get better over time. You could say, suggestion is unclear. I don't know what it's trying to say. From that, the UI for the model could get better. Or you could say, provide more details. I don't understand what you're suggesting here. Okay, tell me.
In my defense, can you go back to a couple of slides?
Yeah.
Go back, one more. Yeah, so this one suggests the spelling because it's British, as Peter pointed out, it's British spelling. Note that it's a quote from a book. I didn't misspell it.
Yeah.
That's a quote from a book in the 19th century where they actually spelled it that way. So contextually appropriate, it didn't recognize that's a quotation from a book. So that underlines phrase there, treated of it. That was from the book. I didn't make that up. Is that spelled correctly, or is it grammatically correct for the time? So
Right.
there's a context and there's context.
Right. And then you're confused, right? Because you could go in and say, add this to my dictionary, but you didn't mean that. You don't want it to add it to your dictionary everywhere. You only want to add it when I'm quoting this book from centuries ago, right? And it doesn't really give you the option to do exactly that.
So many layers to this context story.
Yeah. Okay. So we went past, right? So as I was explaining my conversation with Jurowski, last year there were all these details of how to do this step-by-step pipeline, and that's all been replaced in just the last year. The whole field has switched towards doing this end-to-end. And that's why we want to have this lecture specifically on interfaces, because the underlying technology is there and it will get better automatically. But the hard part now becomes, how do you harvest that technology? How do you build user interfaces that do the right thing? Yes, we can make spelling and grammar suggestions. That's easy. But figuring out the right UI that makes sense for the user, that becomes the hard part. So let's stop there. Yeah.
Has everybody got the QR code? We're good? Okay, so
I added some slides. Very good. Reload. So just reload, yeah. We got a couple extra things. So thank you to Peter for a very lovely talk. A couple things that I forgot to add to the slide deck this morning. One of which is on Friday, that is tomorrow, there'll be a talk about towards globally equitable AI. There is all the information. This is now in the slides in the deck. So if you're interested in this sort of topic, this is probably going to be a great talk. It's at 11:30 over in Gates B3. Okay. The other thing I want to bring up is that next couple of lectures. Next Tuesday, Stephen Johnson will be here from Google talking about Notebook LM. So he's sort of the evangelist for Notebook LM. It's going to be a really good talk. I highly, highly recommend all you people in video land show up. So that's going to be an excellent, excellent talk. And then on Thursday, we have Bean Kim from Google DeepMind talking to us about explanation and interpretability of AI models. And then the following Tuesday, Peter's going to come back and talk about AI supported coding systems, which, you know, you've heard the phrase vibe coding. The master will tell you how this all works. And then just to sort of end this sequence, I'm going to be talking about the extension of what Peter talked about today. Today with natural language systems, I'll be talking about the natural language system in service of conversation. So we're going to take some of the prompts that Peter gave you today about when do you want to talk to a system, when do you not, and we'll go into depth about how to have a conversation with your AI system. All right, we all good? See you next Tuesday or tomorrow, maybe. All right, thanks. That's yours.